Back, everyone. This is continuing with logarithms. These are properties of logarithms. We're getting to some of the bigger ones, so we're definitely getting ready to walk into equations and things like that in the next video. I mentioned this last time in the previous video, the 6.4, that we can go back and forth between exponential form and logarithmic form. And so let's practice a little bit. 8 equals 2 to the third power. This means that 3 equals log base 2 of 8. Again, you can track the a, you can track the x, you can track the y on how everything ended up. I also mentioned before that you could do log base 2 of 8 equals 3, so you could have the equals 3 on the other side. Both are equally correct. Here's one logarithmic form. We want to go the other direction. So this is going to be 3 to the 4th power equals 81. And you can see that is a true statement. And now we are to what I call the big manipulation ones. So this is how we manipulate logarithms, are these 3 here. And what happens is when we're multiplying two things in the domain, we can break them up into addition. When we're dividing, it's the numerator minus the denominator 1. And when we have an exponent, we can actually take that exponent, bring it down in front, and make it multiply. Now, these may seem like strange rules, and they are. They're a little weird. But I want to point out that we have a rule like this. Where we go from multiply to addition. You know, this one. Where we go from division to subtraction. So it's not that outrageous, especially because these are the inverses of exponential functions. This one would be analogous to this one. So x to the a to the b is x to the a times b. So we go from exponents to multiplication like here. So it looks weird and different, but it's actually all stuff that we've been a part of before. So let's use those to split some stuff open. So let's start with part A. Now, ln of 2 is A, ln of 3 is B, and ln of 5 is C. And they want us to rewrite this in terms of A, B, and C. So let's start with A. Now, the obvious one, there's no equals. The obvious one with this one, ln of 6 over 5, is the division. So you can see I'm going to use the division rule here. So ln of 6 minus ln of 5. But I'm going to do more than that because ln of 6 is ln of 2 times 3. And so now I can use this one here and break it up. So ln of 2 plus ln of 3 minus ln of 5. ln of 2 is A, so A plus ln of 3 is B. And ln of 5 is C. So here we are in terms of A, B, and C. Or B. Now, I'm going to take 24 off to the side here and note that 24 breaks up into 2 times 12, 2 times 6, and 2 times 3. So I'm going to rewrite ln of 24 as ln of 2 to the third power times 3, right? 2 times 2 times 2 times 3. I notice I'm multiplying, which means I can break this up into addition. And now I can use this rule and bring that exponent down in front. And going back to our A's and B's, ln of 2 is A, so 3A plus B. So there we are. Not too bad. And let's see if I can keep these in frame while I do these. All right, example 3. So what we're going to do now is we're going to unpack these. Now these ones are a little bit more complicated, to say the least. So for part A, if you remember, there's an old rule that says the nth root of x to the m power is equal to x to the m over n power. And that is what we're going to use here. So I'm going to rewrite this as ln of x. Now the exponent on the x is a 1 over the index, which is the 1/3. So I just went from radical form into this here. And using this here with the exponent, I'm going to bring that 1/3 down. That is my answer there. Part B. I'm going to notice, first of all, it's base 7. I mean, we need to write that every single time. You can't just stop doing that, because as soon as you don't write the base down, it's either ln or it's log base 10, the common log. All right, so first off, I'm going to notice I'm multiplying the x squared times the y, and we're dividing by the z to the 3rd. So I'm going to use these two rules first and sort of unpack those. So log base 7 of x squared plus log base 7 of y minus log base 7 of z to the 3rd. And now I'm going to use this rule here with the exponents and bring the 2 down and the 3 down. Can't do anything with this one. Now you might notice that I'm putting the dot in there. I'm doing that because if I write the 2 right next to the L, it looks like 21 and it's very confusing for students. So I put the dot in. Your online homework system most likely will not let you put a dot in, although it may. Who knows? They get more and more sophisticated as they go. But this is as expanded as we can go with this one. Part C, let's see if I can keep this in the frame. I'm going to notice that I have a 2 that I'm multiplying times x, that I'm multiplying times the radical. Now the radical, I'm going to turn that into x squared plus 1 raised to the 1/2 power. And I'm dividing by the x plus 3. So let's break this up. This is ln of 2 plus ln of x plus ln of x squared plus 1 to the 1/2 power minus ln, minus because it's in the denominator, x plus 3. Now make sure you don't try to get fancy and like think that you can distribute the ln or something crazy like that. You definitely can't. It's ln of x plus 3. We can't do anything else with it. And for my last step, I'm going to take my exponent here and bring it down in front. That's going to be it. So scooch that up. 2 plus ln of x plus 1/2 ln of x squared plus 1 minus ln of x plus 3. That is my final answer. All right. Page 2. Now we're going to go in the other direction. So make sure you keep these rules handy as we will continue to use them. Now we're going to go backwards. And I'll call this A, B, C, and D. So we'll start with A. So what I'm going to do first is I'm going to, so if you remember when we were expanding down here, we used rules 1 and 2 first, and then we took care of the exponents. We're now going to go exactly backwards. I'm going to take care of the exponents, meaning I'm going to bring the exponent back up, and then we'll undo that. Let me show you what I mean. So part A becomes ln of x to the 7th power plus ln of y minus ln of z. And because I'm adding here, that's going to become multiply, and the minus there means it's going to be in the denominator. So I'm going to rewrite all of this as x to the 7th y over z. There we are as a single logarithm. All right, part B. There's 2 ways we can do this. I'm going to take care of inside the parentheses first. So I'm going to bring that squared up. I'm going to take care of that at the very end. So 1/3 ln of x plus ln of x minus 5 squared minus ln of x. So you might be tempted to distribute that 1/3 in there. That would not be wrong. That would be totally fine. I'm going to do this. And the 1/3 in front becomes the exponent. I didn't say, but because I'm adding here, rule number 1 says I can turn it into multiply. So adding means I can turn it into multiply. So this is going to be ln of x times x minus 5 squared, all raised to the 1/3 power, minus ln of x. And I'm going to take it even a step further. And actually, we're not going to do a d. I'm going to make that cube root using this rule that we talked about before and used before. So this is going to be ln of the cube root of x times x minus 5 squared minus ln of x. And now I'm going to do that, and that's going to be, because it's minus, it's going to be in the denominator. That is it. All right, part C won't be as dramatic as that one. And what I'm going to do is I'm going to bring that exponent up. And because it's subtract, I'm going to make that division. And I can actually even reduce that. I sure can. So this becomes ln of x minus 5, x plus 5, x plus 5 to the 4th. And one of those is going to reduce. So we'll be left with ln of x minus 5 over x plus 5 to the 3rd power. Coolness. All right, for the last part, you'll need a calculator for this. It's not hard. We have what's called a change of base formula. And as I mentioned before, most calculators only have base 10 and base e on them. So if we get an expression that isn't in one of those bases, we're going to have to use our change of base formula to work that out. So we started with a base that we can't do anything with, and then we change it to something we can. So my options are I can change it to log base 10 or natural log. Some of the newer calculators do give you the option of having whatever base you want, but they're actually just internally doing this probably. All right, so let's go part A. So we have log base 3 of 5. That I'm going to change that to base 10, the common log. That's going to be the common log of 5 over the common log of 3. By the way, you see me put parentheses around this. Most textbooks don't on something single like this, like just the 5. I'm a former computer programmer, so we had to put parentheses around everything, so it's habit for me. But it's just as correct without, unless your teacher tells you otherwise. So I'm going to use log base 10 of 5, either close the parenthesis and then hit divide, or what I'd like to do is I hit enter first. So that's log of 5 divided by log of 3. So this is about 1.4650. Does it say how many places to go? 4 decimal places, so we're good. All right, part B. This is log base pi. Only a mathematician would think that's funny. And I need to change the base. Now, the last time I changed it to base 10, this time I'm going to change it to ln. ln of 12 over ln of pi. So we have ln of 12 equals divided by ln. And my pi button is above here, so second there. So this is about 2.1707. I want to show you, I chose natural log for this one. Watch if I do common log. Common log of 12 divided by the common log of pi. You'll note it's the exact same answer, as it should be. So hang in there. A little bit more with logarithms coming up.